Hi everyone, welcome to my GCSE Edexcel Maths. We're going to be looking at paper 2, which is the calculator paper. We've got an hour and 45 minutes. I'm going to be talking you through it at the same time. Let's get on with it. Okay, form your page. Right, first question. We've got a set of parallel lines, A, B, C and D, E, F. And they're shown to be parallel by these arrows on the diagram. BEG is a straight line, as we can see. Angle GEF is 47 degrees, as we can see from the diagram. Work out the size of the angle marked X, which is here, and give a reason for your answer. Okay. Now, what you should know about parallel lines is that if you can draw an F on your parallel lines, and we can draw an F here, then the two angles underneath the little lines out of the F's are the same. Now the way I visualize it is just sliding this angle along, and it's the same here. Okay, and now we have that this angle is 47. Okay, therefore X is on a straight line, so it's going to be 180 minus 47. It is a calculator if you want calculator paper, if you want to do it on your calculator. Either way, you get X equals 133 degrees. Give your reasons. Because, okay, angle EBC, which is that one, is 47 degrees, since corresponding angle with angle GEF, okay, which is this angle, and angles on a straight line add to 180 degrees. Okay, and that would get you all of the marks. Right. Okay, question 2. Use your calculator to work out this calculation. Hopefully your calculator has got this fraction button on it. And if it does, that means that you can just type the top stuff into there on your calculator and the bottom stuff into here on your calculator. Okay, you should be able to get your calculator screen to look exactly like that. The calculator that I've got is the Casio FX83 GT. If you've not got that and you want a good calculator for GCSE Maths, why not get one? 18.4 minus 5.9. So my calculator screen looks just like this, and it gives me the answer as a fraction. I press the SD button. Okay, you might have it on your calculator, and you get 43.736. And it says down, write out all the figures, so that is your answer. Part 2, write your answer to part A, correct to one significant figure. Okay, so the first significant figure is the 4. So we look at the number before the 4, which is a 3. And that is not going to round it up, it's going to keep it as a 4. Now because of place values, the 4 is in the tens column. So the 3 is in the units column, and it has to be replaced by a 0, so that we've got 40 and not just 4. Okay, 40 is your answer. Right, clear ink. Moving on to question 3. Pradeep wants to find out how much time people spend playing sports. He uses this question on a questionnaire. The questionnaire says, how much time do you spend playing sports? And it's got 3 options. 0 to 1 hours, 1 to 2 hours, 3 to 4 hours. Just imagine that you were trying to fill this in. What would be confusing you? How much time do you spend playing sport? You don't know if it means this week, in a year, in a month, in a day. It's very, very vague. And what you'd write to say that that's wrong is no time period given, e.g. in a week, stroke month or whatever. Okay, that's the first problem. The second problem is when you decide how much you play sport is the boxes. What if you played sport for 1 hour? There's an overlap. What if you've played sport for 5 hours? There's no option for you. Okay, so just pick one of those. You only need 2 points. No option for over 4 hours. Now with these questions, it asks you to improve the questionnaire. So it says in part B, design a better question for Pradeep's questionnaire to find out how much time people spend playing sports. Right, so if we say how much time, and we can say to the nearest hour, because that'll stop people getting confused, thinking about 45 minutes, what if I'm in 2 hours 45, 2.5 hours, etc. So to the nearest hour, do you spend playing sports? And now we need a time frame, like we said. Let's just pick one per week. Now let's make sure that we improve our options. Because they're rounding to the nearest hour themselves, we don't have to worry about inequalities and things like that. So 0 to 1 hours. Now instead of 1 to 2, 2 to 3 hours, 3 to 4 hours, and then more than 4 hours, just to make sure we cover all the bases. Okay, moving on. On the grid, draw a graph of y equals 3x minus 2 for all values of x from -1 to 3. You notice there's a gap here. The reason for this gap is so that you can use it. Okay, and what you're supposed to use it for is to do a table. So y equals 3x minus 2, and it wants the values of x from -1 to 3. Okay, so we need x's and y's. Okay, and we want to go from -1 to 3. So values of x are -1, 0, 1, 2, 3. You've got your calculator, and what you want to do on your calculator is put 3 times whatever this is, and then take away 2. So we'll start with -1. Now there should be a button on your calculator like this for a -1. Okay, so you're going to type in 3 times by, you can put a bracket, -1, take away 2. And your calculator should give you -5. If you're good, you can do that in your head. Okay, now if you're worried about sums like this, I've got a trick for you. Start from a positive side. Okay, so start from 3. 3 times 3, take away 2, is going to be 7. Okay, and then go to 2. 3 times 2, take away 2, is going to be 4. And then go to 1. 3 times 1, take away 2, is going to be 1. Then 0. 3 times 0 is 0. Take away 2, -2. Now, the reason I've told you that is because if you see the pattern that each time we're going back 3, you don't actually have to work out this one and this one. You can just jump back by 3, if that makes sense. Anyway, just a little tip, you don't have to do it. Now, we plot our coordinates. First coordinate is x is minus 1 here, and y is minus 5 here, put across. The next one, x is 0, y is 2, put across. The next one, x is 1. Sorry, that's a minus 2, not a plus 2. Thought that looked wrong. X is 1, y is 1, put across. X is 2, y is 4, put across. X is 3, y is 7. Once you've got all your crosses, they should be in a straight line. You know the mistake I just made? If you plotted all the rest, you're thinking these are in a straight line, then just cheat. Okay? The cross is obviously going to be on the straight line because y equals 3x minus 2 represents a straight line graph. Okay. Question 5, and it's a starred question. Mr. Weaver's garden is in the shape of a rectangle. In the garden there is a patio of the shape of a rectangle, 2 ponds of the shape of circles with diameter 3.8. The rest of the garden is grass. So let's put a bit of green on it for the grass. Okay. Mr. Weaver is going to spread fertilizer over the grass. 1 box of fertilizer will cover, this is a key bit of information, so I'm going to highlight it, 25 meters squared of grass. How many boxes does Mr. Weaver need? Okay. Right, so what we want to do is work out that shaded area. Now there's different ways to do that. Think of this whole complicated thing as built up by different shapes. We've got this shape, a big rectangle. Okay? We've got this shape, slightly smaller rectangle. And then we've got the circles as well. Okay? Right, let's start off by thinking about this red shape. Let's just work out all of this area. So to get the area of a rectangle, we need the height, which you can see from here is 9.5 meters, and you need the width, which you're going to have to get from here. So on your calculator, you can do 17 take away 2.8. Okay, which gives you 14.2. Now to get the area, 9.5 times by 14.2 on your calculator. It's a calculator paper, you should be using a calculator. This whole shaded red area is 134.9. Now you're not done because there's gaps in the grass. So what you need to do is think, well, we're going to be taking away these circles. So let's take one of the circles, they're the same, so we'll find the area and then multiply by 2. The area of a circle you get by doing pi r squared, which is pi times r, pi r squared. R is the radius, okay? So r equals half of the diameter, which is 1.9. So what you do for the area, you do pi times 1.9 squared. So pi times 1.9 squared on your calculator equals 11.341, etc. Times that by 2 because there's 2 of them, and you get 22.682, etc. And then you're going to do this 134.9. So grass area, take away 22.682, etc. Now I've kept this number on my calculator, a whole number, and now I'm going to press 134.9, take away ants, okay, ANS. And that gets up the last answer that you worked out. And that means that you get 112.217701. One box of fertilizer will cover 25 meters squared. You've got 112 meters squared, so you need to think, how many times does 25 go into that? Okay, and it's going to go in 4 times. You can do it on your calculator, divide your answer by 25. 4 times completely, 0.488. Now you can't walk into B&Q or wherever you want to go and say, give me 4.48 bags full, please. They only get sold in full bags. So you're going to need 4 full bags. Now ideally, you would want about half of this last bag. But you can't do that, so you're going to have to buy 5 bags and have some left over. So you need 5 bags. Okay, and that's your answer. Or boxes. I'm sure the examiner is going to know what you mean. Question 6 now. That was 5 marks. Potatoes cost £9 for a 12.5 kilogram bag at a farm shop. The same type of potatoes cost £1.83 for a 2.5 kilogram bag at a supermarket. Where are the potatoes better value? So, if we do farm shop in blue, £9 equals 12.5 kilograms. And if we do supermarket in green, £1.83, and that gives you 2.5 kilograms. Now I can see that we can get from 2.5 to 12.5 by multiplying by something. So you can do 2.5 times 5. And the way you can think about that, if you've not quite got it on in your head, is do 12.5 divided by 2.5 on your calculator. It tells you that 2.5 goes into 12.5 exactly 5 times. So if we want to go from 12.5 to 12.5, from 2.5 to 12.5 so that we can compare, we can times by 5. So you do 1.83 times by 5, and that gives you an answer of £9.15. Now, because we've got the weights the same, you can now compare straight off. So this is what you're going to be comparing, and it is better value from the farm shop. That's because you only have to pay £9 for the same amount as what you would have to pay £9.15 for in the supermarket. So whenever you want to compare value, get them to the same amount, whatever the amount may be. There's different ways to do this question too. You could have also done it to compare by dividing this by 9, this by 1.83 to compare how much you get per pound. There's a lot of different ways to do this type of math stuff. Question 7. Scatter graph shows some information about 8 cars. For each car, it shows the engine size in litres and the distance in kilometres. The car travels on 1 litre of petrol. Okay. What type of correlation does the scatter graph show? Whenever you're thinking of correlation, you need to think as though you're reading a book from left to right, and you need to say, is it going down or is it going up? Now, if we're going this way from left to right, the points are going down, aren't they? Okay, so it is negative. Going down is negative correlation. Going up is positive. Going down is negative. So that's question A done. Part B, a different car of the same type as an engine of 2.5 litres. Estimate the distance travelled on 1 litre of petrol by this car. So 2.5 litres, we're going to be going from here. Okay. Now, before you can do any estimating, you need to use your points and do a line of best fit. So, let's scroll that back down. There are all our points. A line of best fit has to go through the middle of all the points. Have about the same number on the top as on the bottom. Okay, so there's an example of a line of best fit. Try and do it a little bit better, I think. You would obviously use a ruler and try and go right through the middle. That should be a straight line, okay, with a ruler. Now, once you've done your line of best fit, you go from 2.5, you go up, and you go across. Okay, and you have to read off at this point here. Now, because it goes from, this is 11 here, and you go 1, 2, 3, 4, 5, that means that each little square is 0.2. So this is going to be 10.8 kilometres. That's your answer for part B. That's how much that car with a 2.5 litre engine can drive on 1 litre of petrol. It's just an estimate because it's from a line of best fit. Right, we've got a triangle labelled A. Rotate triangle A 90 degrees clockwise. It's the same way around as the clock goes. In your exam, there's going to be a clock on the wall. You can use it, it's not cheating. Okay, and we rotate it around 0, centre 0. Okay, the origin. Now, imagine we've got this triangle. We're turning it this way by 90 degrees. That means that every line is going to make 90 degrees of its new turned line, if that makes sense. So that makes 90 degrees. This makes 90 degrees. Okay, and the one that's left. So this is a shape that we're going to be getting. Okay. Now, it doesn't say just turn it any old way and draw it on. It says around centre 0. If you've got tracing paper, you can stick your pen onto tracing paper here, draw it on, spin it round. If you don't, imagine that this is a stick holding your triangle and turn the stick. Imagine you stood here, turn the stick 90 degrees, and that is where your new triangle is going to be. Has to be the same size. Be careful to be very accurate. So it's 2 and 3. Okay, that's your new triangle. Doesn't tell us to label it. Part B. We've got another transformation. This time it's an enlargement, and it wants us to enlarge triangle B by a scale factor of 3, and the centre of enlargement is drawn on as a cross, and it's the coordinate 1, 2. So what we need to do is we need to take each point of a triangle and we need to think these are all going to move. Now, to see where they move to, you have to multiply by 3 how far away they are from the cross, which is your centre of enlargement. If we do the first point first, the green point, from the centre to the point it goes 2 across, 3 up. To get the new point, we have to times each of those by 3. So instead of going 2 across and 3 up, we're going to go, might be able to do this a cool way here. Instead of 2 across 3 up, we're going to do it 3 times. 2 across 3 up, 2 across 3 up, 2 across 3 up. Actually, we're going to go 6 across, 9 up, because that's 2 times 3, 3 times 3. So let's go 1, 2, 3, 4, 5, 6 across, 1, 2, 3, 4, 5, 6, 7, 8, 9 up. That's your new point corresponding to this point. Next one, the red point. This was a boring one, it just went 2 across. If you times that by 3, you're going to go 6 across. Here is your new corresponding red point. The blue one goes 4 across, quite boring again. Times it by 3, 4, 8, 12. 12 across. Now you've got your 3 new corners of your triangle, and all you're going to do now is use a ruler. Straight lines are really not good today, I'm sorry about that. And draw on the triangle. That is your new triangle, and there's also a check that you can do by getting a ruler and drawing on the projection lines. If you've done it right, the projection lines will go through the centre of enlargement. Question 9. Linda is going on holiday to the Czech Republic. She needs to change some money to koruna. She can only change her money into 100 koruna notes. Okay, so it's key information. We need to highlight this. 100 koruna notes. Linda only wants to change up to £200 into koruna. She wants as many 100 koruna notes as possible. The exchange rate is £1 equals 25.82 koruna. How many 100 koruna notes should she get? Very wordy question. Okay, let's think about the exchange rate. £1 is 25.82 K. I've not used this currency before, so just call it K. I'm not sure what it actually is. Right, what we're going to do now is we're going to think she wants up to £200. So let's see what £200 changes into. And we get that by multiplying by 200. Okay, so in your calculator, 25.82 times by 200. That gives you 5,164 koruna. Now, we can only use 100 koruna notes. So we can't change this 64 koruna. We can only change 5,100 koruna. So the 64 koruna that we're not going to change. And the question is, how many koruna notes should she get? If it's 5,100, then she should get 51 notes. She's not got 51 notes, something's gone wrong. She's also going to be getting some change from the 200. Because if we exchange this to pounds, it's going to be less than 200 here. Moving on to question 10. M is an integer. Integer just means whole number. Okay, whole number. Like a counting number, 1, 8, 59, 72, 81, whatever. And M is between -2 and 3. Write down all the possible values of M. Right, so if we imagine a number line, there's 0 in the middle, -1, -2, 1, 2, 3. Some people might just write down all those numbers straight away. But the important thing is, the sign next to a 3 means that we do include 3. The sign next to a 2 is not less than or equal to. It does not have the extra equal line, so we do not use -2. All the other ones though, -1, 0, 1, 2 and 3. That's your answer. Part B, solve this inequality. The trick is on this, just pretend that it's an equal sign. I know it's not, but the algebra, the method that you do to solve the equation, is exactly the same unless you start messing around with minus numbers and timesing or dividing. But I will tell you about that if we need it. Right, so if we're solving this as an equation, hopefully you can do this. We want the x's on one side and the numbers on the other side. First thing we're going to do, add 9 to both sides, because this is where you've got most of your x's. You've got 7 x's here, so you don't want any numbers lying around. So that gets rid of the 9. We've still got the 3x. 4 plus 9, 13. Now we don't want any x's on this side, on the right hand side. So subtract 3x and you get 4x and you get 13. Now, a lot of people get very confused here. Don't be confused. All you have to do is think, you've got 4x, you want 1x, so divide by 4. Now, if this was a non-calculator paper, you can just write 13 over 4. It's not a non-calculator paper, you've got a calculator, so that is the same as 3.25. Now, remember we cheated at the start, it wasn't an equal sign. It was a less than or equal sign. So you need to go back to all the equals and change them to that less than or equal sign. Then just less than, sorry. Then your final answer is x is less than 3.25. And that gets you 2 marks. Right, question 11. We have got a horrible looking equation, but remember we're in our calculator exam, so we can use our calculator. It's got an answer that's between 4 and 5. Use trial and improvement to find this answer. And give your answer correct to 1 decimal place. Very, very important. Let's begin then. We're going to guess values of x. And what we're going to do to the x values is what it tells us. X cubed take away 6x. Depending on what our x is, this is going to change. Remember, 6x means 6 times x. Now, what we're aiming for is the answer of 72. And we need to say if we're too high or too low. Right, because our answer is between 4 and 5, let's go bang in the middle at 4.5. And what you type into your calculator is 4.5 cubed. I'm going to do it now with you. Find a little button. It actually says x cubed. So you press 4.5 and then that button, and it cubes it for you. Take away 6 times by x again. Now remember, your x is 4.5. That gives you the answer of 64.125. We're aiming for 72, look, so it's too low. So first one done. Because that was too low, we need to go higher. Let's try 4.7. So let's try 4.7 cubed, take away 6 times 4.7, put it in your calculator. If you want to save time, what you can do is go back to your calculation on your calculator and change the 5s to 7s. 75.623. That is now too high. So what we're going to do is we're going to go lower. Go to 4.6. 4.6 cubed, take away 6 times 4.6 on your calculator. I am now just changing 7s to 6s. And you get 69.736. And that is now too low. Now think about your number line. You're trying to get an answer between 4 and 5. You tried in the middle, 4.5, it's too low. So you went higher. you tried 4.7. It was too high, so you went lower. You tried 4.6. It was too low. So now we know it's somewhere between 4.6 and 4.7. But we do not know where. So the next step, we need to try bang in the middle, which is 4.65. And that's going to tell us if we need to go up to 4.7 or down to 4.6. So the last one in your calculator, you're going to do 4.65 cubed, take away 6 times 4.65. That gives you 72.64, etc. Now that again is too high. Only just too high. We're getting close now. But because it's too high, that means that your real answer was below it. So what you're going to give when you give something to one decimal place is the answer of 4.6. So you write down x equals 4.6. That was the one that gets us the best estimate. Moving on. That was 4 marks. Question 12. The probability that a biased dice will land on a 5 is 0.3. Megan is going to roll the dice 400 times. Work out the number of times the dice will land on a 5. Right. So what you need to do is think she's doing it 400 times. So what fraction or what decimal, what probability do we need to multiply 400 by? We need to multiply it by the probability that the dice will land on a 5, and that is 0.3. So in your calculator, 400 times by 0.3, and that gives you the answer of 120. Out of 400 times, you expect 120 fives. Okay, clear ink. Moving on to question 13. How many minutes they took to get to work? The table shows some information about his results. We can see the table. It's got the time taken in minutes and frequency, which means how many. Sometimes we use the letter F for frequency. Work out an estimate for the mean time taken. What does mean mean then? Mean means add them up, divide by how many there are. Now, usually, if you've just got numbers like 7, 9, 6, add them up, then you can get 22. Divide it by 3, because there's 3, that will give you the average. And it's going to be 7 point something, I'll do it on my calculator. 7.3 reoccurring. That's normal average, okay? This is not a normal average because we haven't got all our numbers written out. What we've got is our numbers grouped into different categories. If it's between 0 and 10, 10 and 20, etc. Now what we still want to do is add them all up, and we still want to divide by how many there are. But it's slightly different how we have to do it. Now, how many there are is to do with this frequency. And we're going to add up these frequencies to get the total number. You might have seen that sign before. It's a capital sigma, and it means sum up. Okay? So on your calculator, you're going to do 3, add 8, add 11, add 9, add 9. Notice I'm doing it on my calculator because it's a calculator paper. There's no point making mistakes. That gives you 40. So you know there's 40 people. And in this question, that information was actually given to you as well. But it doesn't matter. Now what it says is estimate. There's a very important reason why it says estimate. because we do not know the original numbers. All we know is the groups, okay? So to estimate, if your numbers are between 0 and 10, we estimate in the middle that they're going to be somewhere around 5, okay? Now what we do is we call this x. X is a number that we can work with. We can't work with between 0 and 10, it's not a number. So we guess in the middle at 5. The middle of 10 and 20 is 15. The middle of 20 and 30 is 25. The middle of 30 and 40 is 35. The middle of 40 and 50 is 45. Now imagine, here's 0, here's 10. The actual numbers could have been anywhere here. Okay? But we're estimating that we'll take the average that in the middle at 5. It could be inaccurate. It could be they're all over here. Okay? But it's just an estimate. I hope that is clear, some of the background things about what's going on. Now what we need to do is think, well, there's 3 numbers between 10 and 0. So our estimate of 5, we're going to multiply it by 3. That gives us 15. You might have seen this column called f times x. The frequency times x, your midpoint. Next one is 15 times 8. Use your calculator or do it in your head. As long as you get it right, I don't mind. 25 times 11. 35 times 9. 45 times 9. And that is all of your numbers effectively added up. Okay? All the numbers between 0 and 10 added up. All the numbers between 10 and 20 added up. Now it's not perfect because this x value was an estimate. Now to add up all the numbers, we need to add up this column. So we're adding up sigma f times x. On your calculator, 15, add 120, add 275, add 315, add 405. That gives us 1130. Okay. Now, big mistake is divide by 1, 2, 3, 4, 5. No, do not do that. There are not 5 people. There are not 5 numbers. There are 40 numbers. Okay, so you might have seen the formula before. Sigma f of x divided by sigma f. The total numbers all added up, 1,130, divided by how many there are, 40. Do it on your calculator. You get an answer of 28.25. Okay, 28.25 minutes. Job done for 4 marks. Once you understand what's going on with this question, I think it's quite nice. If you understand this formula, it's not as horrible as it might look to you. Question 14. And we've got some algebra to try. Expand and simplify. If you've seen some of my algebra videos on YouTube, you will have seen my banana method. I expand double brackets using a banana drawn on. All this banana does is it makes sure we multiply everything in the first bracket by everything in the second bracket. And that's what brackets make us do. Okay, so p times p is p squared. That one's done. P times 4 is 4p, but it's times minus 4, so you need a negative in front. P times 9, or 9 times p, is 9p, and it's a plus. 9 times 4 is 36, and it's a negative times a plus, so it's minus. Next thing you need to do is think minus 4p and 9p. Well, that sounds horrible, so just write it the other way around. 9p minus 4p, and that's a bit nicer. 9 take away 4 is 5, so that goes to 5p, and your final answer is p squared plus 5p minus 36. Part B. Horrible looking equation that we've got to try and solve. All we're going to do is keep doing the same to both sides until we find our value of w. We're trying to get w on its own. First thing we want to do, get rid of the divide by 3, the big divide by 3, by multiplying by 3. So it's gone from the left hand side now. We've done the opposite of it. If you divide by 3 and then multiply by 3, no effect. On the right hand side, we've got to times all this by 3. So it's 3 times all of this. Now to make sure we times it all, we need brackets. And when we've got a number next to brackets, we don't always need the multiply. So it might look very familiar, a number in front. Now what you have to do is expand the bracket, half a banana. 3 times 4w is 12w. 3 times 2 is 6, and it's a plus. So you've got this equation, which still isn't an easy equation to solve, but we're getting there. You want your letters on one side and your numbers on the other side. Now we want our letters on this side. Why? Because you've got more w's on that side. If you try and get them over here, when you take away the 12w, you can have negatives, which we do not want, if we can help it. So take away 5w from both sides. Here it goes, nothing left. All we've got left is the minus 8. And on the right hand side, we've got 12w, take away 5w, 7w plus 6. Now we want our w's on our own, so let's get rid of that add 6, take away 6. Now you've got to do minus 8, take away 6 on the left hand side. You're on your number line, you're at minus 6, you take away 8 more, it's going to get you to minus 14. So calculator paper, just do it on your calculator if you're not sure. Okay, now we've got minus 14 equals 7w. Final step, we want to divide by 7 because we want w on its own. 14 divided by 7 is 2, and it's a minus. So minus 2 equals w, aka, write it the other way around, w is minus 2. Part C. This is called the difference of two squares, if you've seen it before. If you've not seen it before, and you don't know the rule, let's pretend it's x squared add 0x minus 49, because we've got no x's, have we? Now you might have seen this before, and you might think, oh, I know what to do here. I have to add up to make 0, times to make 49. Now the only numbers that add together to make 0 are a number and the negative version of that number. For example, 100 and minus 100. Put them together, you get 0. 7 minus 7, for example. Put them together and you get 0. And guess what? 7 times minus 7 is 49. That's your answer. It's called the difference of two squares. If you want a quick trick, just do the square root of 49 is 7 and put it in plus or minus in your brackets, okay? I'll try and explain a little bit how things are linked if I can. Let's clear the ink. Part D, I didn't know we had. Algebra, and we are using laws of indices, okay? The law of indices needed here is that when you do power to another power, what you do is you multiply the powers. Okay, so x to the power of a all to the power of b equals x to the power of a times by b is the power law we're going to use. Because we've got brackets here, we want to do the power of a half to everything inside here. So let's just write it again. We want to do the 9 to the power of a half. We want to do the x to the power of 8 to the power of a half. We want to do the y cubed to the power of a half. That's why the brackets are there, to make us do the power to all of it. Now, another rule for you. If you've got n to the power of a half, that's another way of writing the square root of n. Learn that if you do not know it. Okay, so that's the square root of 9, which hopefully you know is 3. This one, the next one, like we said over here, x to the power of 8 to the power of a half is x to the power of 8 times a half. Same with this one. Y to the power of 3 times a half. Okay, so x to the power of 8 times a half is x to the power of 4. And y to the power of 3 times a half, 3 halves, 3 over 2. So the simplified version, 3 times x to the 4 times y cubed over 2. Or y to the power of 3 over 2 more precisely. Okay. Question 15. We've got a starred question, which means we're going to be judged on how well we explain it. It's a functional question. Henry is thinking about having a water meter. There are 2 ways he can pay for the water he uses. The first way, let's put a blue box around it. He has a water meter. He has a charge of £28.20 per year plus 91 pence 0.22 for every cubic meter of water he uses. And 1 cubic meter equals 1,000 litres. If he doesn't have a water meter, he's just going to get charged £107 a year. And actually, when I moved into my new house, there wasn't a water meter. I put a water meter in because I knew it was going to work out cheaper for me. Let's see if it's going to be cheaper for Henry. He uses an average of 180 litres of water each day. Henry wants to pay as little as possible for water, understandably. Should he have a water meter? So what we're going to have to do is work out the price of this, compare it to 107 to see which is less. So he uses 180 litres of water each day. Okay, per day. Now, there's 365 days in a year. Okay, so 180 times 365, because there's 365 days. Do it on your calculator and you get 65,700. That is how many litres he uses per year. Okay. 365 days per year. Okay. Now for each cubic meter of water used, we know the price. So we want to know how many cubic meters. So what we need to do is divide by 1,000. Okay. So divide by 1,000. 65.7 cubic meters. Okay, that is using this conversion. If you know how many liters, divide by 1,000, you get how many cubic meters. Right, so he's going to get charged 91.22 pence for each one. On your calculator, He's going to get charged. Now on my calculator screen I've got 5993.154. You need to understand what's going on here. Okay? This is in pence. So this is in pence. Very, very important. Okay? So if we want to know in pounds, well, you can just jump the decimal point. Okay? So it's £59 93 because we can round to the nearest pence. Now what we need to do is we need to add on the charge. So we're going to add on 28.20 for the charge. And this is going to tell us the total cost. Okay? So on my calculator, add on 28.2. Yeah, I know I could have done it in my head, but I'm being lazy, aren't I? And why not when you've got a calculator? So the charge for that with a water meter is £88.13. At the minute he's charging 100. He's paying 107. So the answer is yes. Have a water meter, and I know this is true to real life, where I decided to have one and save some money too. Okay, so maths is good, helps you. Right, done. How many marks is that one? That's 5 marks. Okay, question 16. We have a right angle triangle. In your head you should be thinking, okay, I've learnt about triangles, I've learnt Pythagoras, I've learnt trigonometry. Which one is it going to be asking me though? I don't even need to read the question. I know it's trigonometry. That is because we have an angle. You do not need an angle for Pythagoras. Okay? So, let's now read the question. It's a right angle triangle. Yeah, we can see that. MN is 9.6. We can see that. And LM is 6.4. We can see that as well. Calculate the size of the angle marked X. Give your answer correct to 1 decimal place. I've told you it was going to be trigonometry, which is SOHCAHTOA. We've checked by reading the question, and it is SOHCAHTOA because we're trying to find the angle. So you write out SOHCAHTOA, where O is opposite, A is adjacent, H is hypotenuse. And you label your triangle. Now, what does O mean? O means opposite the angle. So this is O. A is adjacent to the angle next to it. Now I know this one's next to it too, which is why I usually label H first, which is opposite the right angle. The last one left has to be A. Then you circle the ones that you've got. You've got H and you've got A. H, A, H, A. And the formula that you use is the one with both. So we're using the CA formula. Now CA is just a nice way to remember that cos of the angle equals adjacent over hypotenuse. In this case, our angle is X, our A is up here, and our H is over here. So let's write out the formula with what we know. Cos of our angle X, and I always put brackets, equals adjacent, which is 6.4, over hypotenuse, which is 9.6. Now, because it's a calculator paper, we can just leave it like that because we can put fractions and complicated things into our calculator. The aim is to figure out X, to get X out of that horrible bracket that it's in with the cos. So what we need to do is the opposite of cos, okay, to get rid of it. Now don't start telling me to divide by cos, because this isn't a multiply here. It's not cos times by x. What it actually is cos of x, okay, the cosine of x. So there's a special inverse of cos, which is cos to minus 1. Okay? And cos opposites. So what we want to do is the opposite of cos, which is cos to minus 1. We do it to both sides, and all it does is it gets rid of that cos, so we're just left with x. But obviously, we haven't got any cos on this side, so we have to do cos to minus 1 of the right-hand side. Now, I've left it like that because that can go straight into your calculator. You might need to press shift and then cos to get cos minus 1. The fraction button, 6.4 over 9.6. Close your bracket and you get the answer 48.1896 blah blah blah. Read the question. 1 decimal point. You do not want to lose a mark if not rounding correctly. 1 decimal point, you want one number after a decimal point. Look next door, the 8 is going to round it up to a 2. So 48.2 is your answer. Question 17. Liam's a lucky lad, he's got £6,200 and he is investing it for 3 years in a saving account. He gets 2.5% per annum compound interest. Compound interest is great, guys. You should really look into it. Okay? What it means is you get interest on top of your interest. So the amount that you have in the bank keeps on building up and building up. Okay? I'm first going to show you what people do as a mistake. They go, right, 6,200. I'm going to get 2.5% interest. So let's find 2.5%. I'll show you how I do this in a minute. Let's find 2.5%, 155, and I'm getting it for 3 years. So if I add up all this together. That is not right, because you're going to get interest on this extra, and you're going to get interest on this extra. So actually, the numbers here and here are going to be different. You're going to get more. So let's see how we should actually do it. So, first year. In the first year, we are going to get 6,000, 2.5% of 6,200. Okay? Now, there's a trick. We want to find 100% add on 2.5, which is 102.5%. And the trick is to use a multiplier. Convert it to a decimal, which you do by dividing by 100, 1.025. That is called the multiplier. I love multipliers because it does the work for you. Okay? If you want to find 102.5% of 6,200, grab your calculator, do 6,200 times by your multiplier. Okay? And you get 6,355. Like I said, we've added on 155. That's the first year. Second year. What you're going to do, I've just talked about how to get the multiplier. We're going to do the multiplier times by the new amount. And we get £6,513, 87.5 pence. That's the second year. Third year, we're going to take this amount and times by our multiplier again. It doesn't matter which way around. and we get £6,676.72 to the nearest penny. So that's how much we're going to get with compounding. Let's see what the mistake you might have made, what answer you could have given. 6200, add 155 times 3. This is called simple interest. 6665, simple interest. This one, compound interest. I know which one I would rather have. The compound interest, because you get interest on the new amount. Okay? So, let's give it as an answer. How much will you have after 3 years? £6,676.72. Okay? Just in case anyone's just tuning in looking at that, let's cross it out. Before I go off this question, let's look at a quick way we could have done it. Our multiplier is 1.025. How many times did we times by it? 1, 2, 3. If we times by a number 3 times, that is the same as doing that number cubed. And to be honest, if I was doing this question in my exam, I wouldn't write out all that stuff. I would just write 1.025. We're timesing it 3 times, so it's cubed for 3 years. And we're timesing it by our original amount, 6,200. Do that on your calculator, 6,200 times by 1.025 cubed. And guess what? You get the exact same answer. Okay? Just a little top tip for you there. I'd like to show you quick ways to do things when there are quick ways. 3 marks. Question 18. Diagram shows a quadrilateral ABCD. AB is 16 centimeters, AD is 12 centimeters. Angle ACD is 40 degrees. Angle ADB equals angle CDB equals 90. All of that is on the diagram. Calculate the length of CD. Calculate this length. Can you see this triangle here? This quadrilateral, as they called it, 4-sided shape, is made up of 2 triangles. Put them together. Can you see? So, like the one a few questions ago, you're thinking either trigonometry or Pythagoras. Or hey, maybe even both. But that's a little clue for you. Let's label what we've got. We've got this angle as 40 degrees. And we've got this length as 16, this one is 12. What would be really nice to know is this length. Because then what we could do is we could use trigonometry to find this. Let's call this x because our ultimate aim is to find it. Before we can get that, we would really like to know what this is. Let's use a different letter, say y. So let's think of this as 2 questions. Question 1, question 2. And our answer for y is going to feed into that question. So, Pythagoras. Now, I teach Pythag in a way that doesn't actually need the formula most of the time. If you're comfortable with the formula, fine. Okay? This has just come from the formula anyway. So to get a shorter side, we know it's shorter because it's not the hypotenuse, which is the longest. Shorter side, what we're going to do is square it, subtract square root. Okay? So, square it. Sorry, we want to square the big one first. Square it, 16 squared. And that gives us 256. Square it, 12 squared, 144. Subtract. Now the reason I did this first is because you want to subtract the smaller one from the bigger one. So 256, take away 144, 112. So squared it, subtracted. Final thing, square root 112, square root ants. And my calculator says 4 root 7, or 10.583000. Now we want to give our final answer correct to 3 significant figures. It'll be fine if we work with 3 decimal points here. So, like we said, that's our answer to y. So that feeds into there because it's from the same shape. Okay, it's from the same shared line. So now let's get on to the trigonometry bit. This part is trigonometry because we've got the angle. So it's SOHCAHTOA again. Okay, now let's label it. There's the right angle. Opposite the right angle is the hypotenuse. Opposite the angle is the opposite. The other one is the adjacent. So the things that we have are opposite and hypotenuse. When I say have, either have or want to find out. Opposite hypotenuse, what we're going to use is this SOH formula, which stands for sine of the angle equals opposite over hypotenuse. Running out of space a little bit. So our angle is 40 degrees. Okay. Our opposite, just going to pull this in actually, save me writing it again. That's our opposite. And our hypotenuse is x. So let's pull that one in as well. I can't just write it again. Okay. Now we want to find x. So what we're actually going to do to this formula is we are going to multiply by x to get x up here and divide by sine 40. All at the same time because we're running out of space. 10.583 divided by sine 40. Get that into your calculator exactly how it's written there. So I press the fraction button first, 10.583 on the top and sine 40 below. By the way, your calculator has to be in degrees here, which it should be anyway. So x equals 16.4642, etc. We want 3 significant figures. So it's testing our rounding again. 1, 2, 3 numbers. Look at the 6. 6 is going to round the 4 up. So x is 16.5 centimeters. Okay. So that length is 16.5 centimeters to 3 significant figures. Quite a large question. The hardest bit of that question is realizing what you had to do. But you get rewarded for it with 5 marks. Question 19. Find the value of p, give your answer in the standard form, correct to 2 significant figures. We've got a formula that p squared equals x minus y over x times y. What a horrible question, because look at x and y. Not very nice. I want us to split this up into parts. So p squared equals, first part, x minus y, divided by, second part, x times y. Now we can work out the 2 parts. Look what I'm doing on all these questions. I've split it up again into at least 2 questions. Now I prefer the look of question 2, which is x times y, because I know it's easier to do. So x times y is this 8.5 times 10 to the 9 times by y, 4 times 10 to the 8. Now your big numbers are just normal numbers. So you can do 8.5 times 4 on your calculator. or if you want, you can do it in your head, but I wouldn't advise that in a calculator paper. Now, using your power laws, you've got the same number to a power, same number to a power. When you're multiplying, you can add the powers. So it's 9 add 8, 17. Okay, that's x times y. It's not yet in standard form, but we can worry about that in a minute. X take away y is not very nice. Okay, it's really not. So, x on the top, 8.5 times 10 to 9. We're going to do x minus y written like this. So, times 10 to 9 is going to be 8. Let me show you this slightly different way. 8.5 times by 10 to 9. Now the 9 means that you move it to the left 10 times because you're timesing by 10 9 times. Timesing by 10 9 times. So what we're going to do, imagine we've got an infinite supply of zeros around. Okay. We're going to move it to 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. It goes there. Okay. Which means that it's going to be the 8 and the 5 moving. And actually, the way you can think about it is you're going to have 9 numbers after the 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. These zeros will just go anywhere you've not got a number to hold the place value. Right, the next one, times by 10 to the 8, it moves 8 times. Okay, so it starts here as a 4. 1, 2, 3, 4, 5, 6, 7, 8. And like we've talked about, the zeros are the placeholders. Add them together, we get 8, 9, 1, 2, 3, 4, 8. If you're really good, you can think of that in your head as 0.4 times 10 to the 9. And once they're the same base numbers, once they're the same 10 to the power of 9, that means they're lined up. You can add them. You're going to get 8.9 times 10 to the power of 9. Okay? This thing with column addition is just showing you what's going on. So, that is one part, that is another part. Let's put it into the question. Okay. So, what we're doing now is we're trying to solve this. So, what we're going to do is we're going to have to square root to find p. And it's saying give your answer. Well, I'll tell you, if I wrote this exam paper, I would have written give your answers, because whenever you square root, you should get a plus or minus. And it's not said anything about p. But that's another story. Let's see how we can simplify this down first, because our calculator is going to struggle with that. You've got 10 times itself, 9 times there, 17 times there. What you can do is you can cancel out the 9 times and have 10 times by itself, 8 times on the bottom instead. Okay? So that's p squared. Like I said, usually you'd have to do a plus or minus when you square root. Square root both sides. And you can put that into your calculator. And you get the answer in standard form, correct two significant figures, 5.1. Hopefully your calculator will already do that on the screen for you, times 10 to the minus 5. Right, moving on. Make t the subject of the formula. So a tricky algebra question. Make it the subject means you want t equals, and the GCSE question is reminding you that that's what you want. So let's try and simplify this to try and get t on its own. Now we'll come across a problem when we start doing this that t is on both sides, so I will be showing you a trick how to deal with that, but not quite yet. Let's deal with the left hand side and expand out the bracket. 2d minus 2t, 4t plus 7. We want our letters on one side, our numbers on the other side. We've got more letters on this side, so what we're going to do is we're going to get rid of the letters on the left hand side. And all we're going to have left, when I say the letter, I'm talking about the t, the letter we're interested in. 6t plus 7. Now we want t to be on its own. Let's take away 7. 2d minus 7 equals 6t. We still want t on its own. We've got 6 lots of t. So we divide by 6. Now you get left with t on the right. And on the left, we're going to think, well, divide. We can't divide it because we don't know what this is. So let's put a big line to stand for divide, and then we're just going to switch it round. 2d minus 7 over 6. That's your answer. Done for 3 marks. Oh wow, proof question. Very, very nice. Proof questions really make sure you're good at algebra, and you can also think about what's going on in general in maths. If you like maths, you start doing more advanced maths, there's going to be a lot of proofs for you. Now let's first talk about what it means to be a multiple of 8. If our number is say x, if it's a multiple of 8, that means you can write 8 times a number. Okay, remember that. So prove that this is a multiple of 8. What we're going to have to do is we're going to have to simplify this algebra and somehow show that it's some number times by 8. Okay, that means it's a multiple of 8. For example, 24 equals 3 times 8. So 24 is a multiple of 8. Okay, if we do it in general algebra with n's, where n can be any number, then we've proved it for all values of n. So back to the algebra. When you have a squared on a bracket, squared means times it by itself. So times it by itself, the whole thing. Don't start just doing 2n squared, add 3 squared, because it's not right. It's in brackets, you've got to times it by itself again. Same with the second bracket. 2n minus 3 times 2n minus 3. Okay. Let's times out the brackets using the banana method. 2n times 2n, 4n squared, plus 6n, plus 6n, plus 9. Move on to the blue one. Do it in, of course, we do it in. Now look, be careful here. Because about negative, there's a negative here, and it's negative of all that. So get into a good practice of putting big brackets. It's minus all of it. Okay, we'll do it in red. 2n times 2n, 4n squared. 2n times minus 3, minus 6n. Minus 3 times 2n, minus 6n again, plus 9. Right, because of this negative, you're taking away all of this. So it actually swaps the signs. It's minus 4n squared, and it's minus a minus, which makes a plus 6n. Minus a minus, which makes a plus 6n. Minus a plus, which makes minus 9. If we put that together with what we had before, now we can start to simplify this. Add 9, minus 9, they disappear. Okay, 6n, add 6n, add 6n, add 6n. That's 24n. And the 4n squared minus 4n squared disappears. So the answer for all of that is 24n. Now 24, wow, what a coincidence here. Not done this question before. There you go, just popped into my head. We know that 24 is 8 times by 3n. Okay? Therefore, it is a multiple of 8. Because it's 8 times a number. Okay? That's the definition of a multiple. Okay? Question 3 done. Three marks, sorry. Question 22. Big hint for you here. Can you see? Give your solutions correct 3 significant figures. When have you ever solved an equation, put it into 2 brackets and got a decimal? Have you ever done that? No, not really. You might get a fraction. Very rarely a decimal to 3 significant figures. Okay? So you should be thinking now, when do I get a decimal answer from a quadratic? 3x squared minus 4x minus 2. The answer is when you use the quadratic formula. You don't have to learn the quadratic formula. It's on the front page of your formula book. So if you go to your front page, you'll find it, the quadratic formula for a quadratic equation. And it says that if you have the equation ax squared plus bx plus c equals 0, you can use x equals minus b plus or minus square root b squared minus 4ac all over 2a. So you look in your front of your book, you write that down on your page, and now you need to think, well, where does a, b and c come from? A is the number in front of the x squared. B is the number in front of the x, but be careful because that's got a minus in front. And C is the number on its own. So circle them. Let yourself know what's going on. Just to make it very clear what's going where, let's colour code. And let's use now the formula. So, x equals minus b. So, it's going to be minus 4. 2 minuses make a plus. Okay, so you don't need that. That's the first bit of the formula. Plus or minus the square root of b squared. So if you're doing this on your calculator, you need brackets around the b because it's a minus. If you don't put those brackets in, you're going to get it wrong. Minus 4 times by a, which is 3, times by c, which is minus 2. Because it's a minus, you need brackets again. And all of that is divided by 2 times by a. Your a is 3. Now you've got it like that, you can put it into your calculator. Okay? So it's going to be, now when you put it in, this plus or minus sign means do it once with plus and do it once with minus. That's all. Okay? That's representing 2 formulas. You wouldn't want the examiner or whoever wrote the formula book to write it out twice, once with a plus and once with a minus, would you? So they've written it out once and put that sign. So you just get your calculator to look just like that with a plus there. Okay, so 4 plus the square root of minus 4 squared, which is 16. Take away 4 times 3 times in brackets minus 2. And that's all divided by 2 times 3, which is 6. Now, if your calculator says 2 plus root 10 over 3, that's good. Don't forget you've got to do it once with a plus and once with a minus. Okay? Let's do it once with a plus. So, with the plus sign on your calculator, press SD, get it as a decimal, 1.72. Now, go back to your formula where you wrote it in. This time, put a negative instead of a plus sign. And this time you get 2 minus root 10 over 3 minus 0.387. 3 significant figures, remember? So x equals that, or x equals that. A-star question, quadratic formula solved. Okay. 23. Max wants to take a random sample of students from his year group. Explain what is meant by a random sample. So, random sample means everybody has the same chance or probability being chosen. And the way they're chosen is completely at random. Okay? They are selected at random. Describe a method Max could use to take his random sample. Well, just think of real life. How could you do things randomly so that they've all got the same chance? Well, what you could do is you could put names in a hat, or you could do a slightly more nicer way than doing names in a hat, which might involve a lot of writing and ripping up paper. You could assign a number to each student, and then you could use your calculator and use the random button on your calculator or on Excel, whatever you want, to select numbers and pick those students. Just think how you do it in real life to make it random and fair. Lots of different ways you could do it. Right, the table below, part B, shows the number of students in year 5 in 5 year groups at school. So we've got year 9, year 10, 11, 12, 13. Lisa takes a stratified sample of 100 students. Work out the number of students from year 9 she has enough sample. Stratified sample, what it means is, say you had 20 girls and 10 boys. If you want a stratified sample, it's not fair just to pick, say if you want 6 people, it's not fair to pick 6 boys, because it doesn't represent what you had originally. Originally you had 20 girls, 10 boys. So you want the same ratio. So you want 2 girls to every 1 boy. So if you want 3 people, you would have 2 girls, 1 boy. If you want 6 people, you would have 4 girls and 2 boys. Anyway, back to our question. We're trying to make it fair. So what we need to do is we need to figure out what fraction of year 9 we want. So what fractions are for students are year 9? Okay, so we've got 239, year 9, out of how many? Well, what you want to do is add up how many you've got. So on your calculator, 239, add 257, add 248, add 190, add 206. And the total number is 1,140. So this is a fraction that are from year 9. So we want that fraction to be represented in our sample. So it's 29 out of 1,140 of 100 students. Now when it says of, if you want to find that fraction of 100 students, all you need to do is multiply. So on your calculator, 239 over 1,140, times it by 100, and you get 20.9649, etc. You cannot give that as an answer. It's asked you how many year 9 students you want. You can't cut people up. They've got to be in whole numbers. Now, what do you think you're going to pick? Are you going to pick 20 or are you going to pick 21? Well, it's much closer to 21, so you're going to pick 21 students. That way, it'll be fair that it's the right fraction of the year group in your sample to be representative. And that is what stratified sampling does. Question 24. ABC is a triangle. AB is 8.7 centimeters, angle ABC is 49 degrees, angle ACB is 64 degrees. Calculate the area of a triangle. Okay, I think you get the formula for the area of a triangle in front of your exam. It's a half AB sine C, where C is an angle and you know 2 of the other lengths. Not just any 2 of the lengths, the other lengths are either side of the angle. Okay? Now the problem with this question, I'm guessing it's worth a fair few marks, 5 marks, is because we do not know 2 of the lengths. We only know 1 of the length. So what we're going to have to do is we're going to have to use the sine rule to find out another length. Now remember I said you want the angle and 2 lengths outside? Hey, why not let's find out this length. Okay? Failing that, we could work out 2 new lengths, but that's too much work. Now for the sine rule, let's call this x. What you need is a length and its opposite angle, and another length and its opposite angle. So we need this angle here. Now to find that, it's easy because there's 180 degrees in a triangle. So you just take away the other 2 angles. 180 minus 64 minus 49. And you get 67 degrees. Now the sine rule says that A opposite is the length A and C opposite is the length C. The sine rule says that C over sine of the angle C equals A of A over sine of the angle A equals B over sine of the angle B. It's basically 3 different formulas in one. You don't need all 3 things with the 2 equal signs. You just need this one. And again, this is on your formula page. Now let's substitute in what we know. The length C is 8.7. The The length A is what we're trying to find. It's x. The angle C is 64. And the angle A is 67. Now we want x as our answer, so we want to arrange this equation by multiplying up by all of this. Okay, and that'll get it to this side. So x equals sine 67 times by 8.7 over sine of 64. On your calculator, you should get that x equals 8.9101523 or something like that. Now that x is effectively, we can say, our A here. Our B, not to confuse you, but that has to be here now. So we're doing new labels. That can stay as A, that can be B, and now the angle here is the angle C. So we've got A, B, and C. Okay? And we use the formula half times A, which is our x, which we found. Can we put it up here? Need to erase that first. That is our A. Our B is 8.7 with our new label, times by sine of our angle 49. Okay. So now you've put all of that in your calculator, 0.5 times by, you can use it as your answer if you didn't delete it before, 8.7 times sine 49. I think I kept my answer in. And you get 29.251967. And we want it to 3 significant figures. So we want the first 3 numbers. We want to know if we want to round up or down. We want to round up to 29.3 centimeters squared because it's area. Okay, so we want to get the units correct. Question 25. Caroline has 20 biscuits in a tin. She has 12 plain biscuits, 5 chocolate biscuits, 3 ginger biscuits. Straight away, let's go. P for plain, C for chocolate, G for ginger. She takes at random 2 biscuits from the tin. Work out the probability the biscuits were not the same. Right, do I show you the way I would do it or the way that makes it a bit clearer? Okay, I'm going to show you the way literally that I would do it. If you want to work out the probability that they're not the same, it is probability that they're not the same. It's 1 take away the probability that they are the same, because they're either the same or not the same, so those 2 probabilities add up to 1. So the probability that you get the same, you could have plain then plain, or you could have chocolate and chocolate, or you could have ginger and ginger. Okay? So, P and P is going to be the probability of getting P times the probability of getting P again. Now, in total, there are 20 biscuits. Okay? So our first probability is out of 20. There's 12 plain to start with, so it's 12 over 20. Now, once you've taken out a plain biscuit, You're not going to put it back again because you're taking 2 out. So there's only 19 biscuits left. And if you've just taken out a plain one, there's only 11 plain ones to pick. If you do that on your calculator, 12 over 20 times by 11 over 19, you'll get a fraction, 33 over 95. Chocolate then chocolate. Now before any are taken out, there's 20 biscuits. There's 5 that are chocolate, so it's 5 out of 20. Once you've taken a chocolate biscuit out, there's only 4 left to choose. 4 chocolate left to choose and 19 to choose from. So on your calculator, that's 5 over 20, aka a quarter, times by 4 over 19, which gives you 1 over 19. Ginger then ginger. At first, there's 3 out of 20. Once you've taken one out, there's 2 left out of 19. So on your calculator, 3 over 20 times by 2 out of 19. 3 over 190. Right, so it's that or that or that. Now because you've got options, you can add any of those, it's going to be getting more likely. And when you're saying I want that or that, in probability, you're going to add, okay? So we're going to add 33 over 95 plus 1 over 19 plus 3 over 190. Okay? And this is going to give us a probability that they are the same. On your calculator, 3 over 190 plus 1 over 19 plus 33 over 95 gives you the answer of 79 over 190. Okay? Now you want a probability that they're not the same. So what you need to do is 1, not same, 1 minus 79 over 190, which is going to give you 111 over 190. Now, I just showed you one way to do that. There are other ways involving tree diagrams and things, but I just wanted to show you how I would do that, what I think is the most straightforward way of going about that question. Right. So, moving on to the next question, which is 26. Let's clear the ink. That one was 4 marks. This looks like the last question. Yeah, vectors question for question 26. Okay. OAB is a triangle. OA, the vector OA, which gets you from O to A in that direction, is labelled A. Okay, that's what this says. That is the vector A. It doesn't matter where you put it, that's the vector A. Okay? The vector B, from O to B. To get from O to B in that direction is the vector B. Now you can put it anywhere you want. Okay, let's delete that one. So we've got 2 vectors, okay, A and B. If you do A add B, you'd start off doing A and then do B at the end, okay, etc. Anyway, find A to B in terms of A and B. So we want to know, how can we go from A to B using these 2 vectors? You're probably going to get really confused and think, well, if we're starting from A, we're going to keep going away from it wherever we go. Now the trick is, even though that's your vector A, if you do the exact same thing but backwards, that is minus A. Okay? So that's very important. So what we can do is we can go along And we can do minus A and then up B. And that will get us to where we want to be. Okay? So minus A plus B. We put the line underneath to show they're different from numbers. It's not just a length, because it's got a direction as well. And another way to write that is B minus A. Okay, same thing. Now let's think, how does that work then? B minus A, how is that the same thing? Look, gets you to the same place. Okay, it doesn't matter which one you do first. Right, P is a point on AB such that A to P, let's move these out of the way. A to P, that's that. And P to B, that's that, are split in the ratio 3 to 1. So that basically splits into 4 parts. Okay? And you've got 3/4 and 1/4. So if you split that whole part up, A to B, A to P is 3/4 and P to B is 1/4 of it, of the length. Find O to P in terms of A and B in its simplest form. So we've got to go here, here. Okay? Or, if you don't want to do that, you can go up here, down here. So let's go for that, okay? Or should I? The only thing I'm thinking about is if we already know what A to B is, okay? If we're coming down it, we're going backwards. I don't want to confuse you at this stage with going backwards, so I reckon thinking the other way is going to be simpler. Doesn't matter which way around you do it, I'm just thinking what's best to show you. We're going to go along A, and then we're going to go up here. Okay? So, O to P, we're going to go along A, we've just talked about that. So we're here. And now, we know that that is B minus A. We don't want to go all the way along it. So we want to go 3/4 of that. 3/4 of that vector. Okay? Now it just wants you to simplify the vector algebra. And you can do pretty much all the same things as normal algebra. So times out your bracket. 3 over 4b minus 3 over 4a. Okay. And what you can do is you've got the whole of a, take away 3/4 of a is going to give you 1/4 of a. So the answer is 3 over 4b plus 1/4 a. That's done. That's the whole paper. Hopefully we got full marks there, but it's quite a tricky question. Feel free to leave comments, ask me questions, whatever. I don't mind, it's all good. I'll try and answer as much as I can. I hope you've enjoyed that. It's been a nice journey with you there. And I hope it helps you, more importantly, to achieve your full potential in maths. Thanks for watching. Keep up the good work.